Okay, whoops. Hi, I have been sitting here for the past age, I guess, streaming, but not streaming because I forgot that there was a whole other button to press. Uh, my bad. I am partway through a design process right now. I guess we can kind of backtrack on these a little bit. Wow, I am very sorry about that. That is, yeah, my bad in a lot of ways there. It has been an awfully long time since I've streamed, and I guess it's showing at this point in time. So to very, very quickly recap what I have been messing around with, and actually we're going to redo some of this, I think, because I think some of it is interesting. Hello, everybody. Oh, this is... Yeah, okay. Late night impromptu streaming. Welcome. This is what this is now. I'm going to jump over to my Fusion 360 instance, and we're going to have a quick chat about what it is we're actually doing here today. So this here is a photo of the hijinks bar. If I open up the other instance I've got of this image, these are the images directly from Fingertech's website. A little while back, I was looking at the Fingertech website. I found the hijinks bar, and I was like, oh, those are so pretty. I need one of those in my life. So I have bought one. It is on its way to me. So it is on its way here. The problem with that is that these are a 6-inch 77-gram weapon bar. And the heaviest weapon that I have ever run, or at least run until this point in time, is this guy. This little pink guy here. It is like a 50-odd gram weapon, and I have barely made weight with this bad boy. So I need to design a robot that is as light as possible. So that is what we're going to do this evening, and that is what I have been starting to do while completely not live. My OBS has been going this entire time. I just forgot to click the one button on YouTube that lets me go live. So the question is, how do we fit a bar that is much, much heavier than my hot pink bar here into an ant weight? And the answer to that is save as much weight everywhere as we possibly can. So let's have a look at some of the components that I've got to do that. First up, we have these. These may look like a regular N20, but they are not. They are an N10. This here is a regular N20. So you can see this boy is ever so slightly smaller than our N20, and I've measured it out now, and it's like 5 millimeters shorter or something. It's not a whole lot, but it does have one advantage to it, and that is, if I can get my scale open, you have a look at the weight of these two things together, and we'll see that if I put down, so this is the N20, put down the N20, N20 is about 9.4 grams. The N10, on the other hand, is 8.2. So we save a whole gram by swapping motors, and that means we save 2 grams by swapping the two. There are other options for motors that are smaller and lighter, and I've used them in flea weights in the past, but they're plastic geared, which means that putting a very, very heavy weapon on top of them, they're just going to explode in the first hit. There is no question about that at all. Yeah. Okay, how is this going to impact the pits at ARC? This is going to be a very, very heavy weapon on top of an ant-weight robot. This weapon is going to be half the weight of the robot, if not slightly more. If anything, when I hit somebody, the entire robot is going to go flying. I'm probably going to go over the walls. If I don't go over the walls, there's a high likelihood I'm going in the pit. That is what it's going to be, unfortunately. This is the price I pay for the absolute chaos that I'm about to inflict on the arena when I get this whole robot going. Anyway, so that's the weight of those. The other things that we're doing, actually, let's leave the scale on because we need that on again. So The other things I'm doing, I'm moving away from the 1806s. This is the 1806 that I've been using recently. These are just kind of a cheapy 1806 from like AliExpress or eBay or one of those. They're the same thing that I used in the walking robot that completely exploded it, which was a lot of fun, but they were spinning a lighter weight weapon than what I'm going to be spinning, so I can't be doing that. So instead, I have found these, which, hang on, let's get the camera to focus. There we go. We have, this is a 1507, as you can see. It spins faster. It's slightly smaller in some aspects and not all, but it does have a 3mm weapon shaft at the bottom, or like motor shaft in through here, so it's actually going to be stronger than these 1806s. Now, the problem with this that I found out earlier while I wasn't actually streaming was if we throw down the motor, that's about 18 grams. Our new motor is actually slightly heavier, but it also has a lot longer wires. So cutting these wires all the way back is probably going to save us a decent amount of weight, maybe a gram. So the difference between these two motors is actually fairly similar in terms of weight. The other thing we have going for us with this guy is that it has quite a long weapon shaft, so we can probably trim this down a little bit and still have a lock nut going on, and yeah, get that all working. You love my fight recap videos. Cool. I'm glad. I really enjoy making fight recap videos. There was supposed to be one out this weekend. Unfortunately, things got very, very busy. That's also partly why I'm streaming very late at night. I was supposed to get CAD stuff done this weekend and just ran out of time. Life happens sometimes. So yeah, there was supposed to be one out. It might come out Tuesday. It depends on how things go this evening and tomorrow. For me, that will be an Exilus fight report video, which it should be good. I enjoy fighting Exilus. In actual fact, at some point in the near future, we need to do another live stream or something where I redesign Exilus, because as much fun as that robot is, there are some flaws in the design that I need to fix up now. In actual fact, I might talk about those a little bit more in the fight recap video. That, again, it might be Tuesday or it might be just be next week's video at this point. I don't know. We'll see how we go on all of that. If you grab the CAD file for the 6-inch fingertech band, the whole spacing for the mounting and everything will be exactly the same. Oh, okay. That's a good thing to know. Interesting. I did not actually think about that, because Fingertech themselves, I'm going to quickly do that while looking at this, because Fingertech don't give you the CAD for the hijinks bar, because they don't want you to have that. Or, well, because it's, you know, it's not their design to give out effectively. It is Hijinx's design, so they're not giving out the CAD of that. The 6-inch titanium bar? Okay, I am going to have a look at this later. The problem that I'm seeing here is that if I go back to... Yes, so the problem that I'm seeing here is if we actually have a look at this right in the middle here, this shape is the thing that I don't know about at this point in time. It's this kind of like weird clover shape thing going on, and all I really need to know is if a 5mm bolt is going to fit through that and not be too loose, which it's very, very hard to tell what that is here, but I think looking at this very, very blurry photo here, that is going to be right. Now, the reason I've got this one rather than this one is that this one has kind of like a parallax thing going on, like the blade is kind of tilted at an angle. It's not straight to the camera, which means you can't get an accurate idea of the hole diameter, unfortunately. So this one is from a different image of the team holding it up in their fingers, and it is actually just ever so slightly straighter on, which means that while the pixelation in this is just disgusting, you can basically just about tell that it is around about 5mm. It's close enough that I'm like, yeah, I think this will be okay for what we're trying to do here. Yeah. Will your new PCBs be lighter because they save on wiring, or will be heavier because of PCB material? I didn't think the file was available for the FingerTech, for the hijinks bar. Yeah, if you go to CAD files, it says we have agreed not to give out CAD files for team blades for robot designs. The OD thickness and weight are all specified, which they are. So it's a 5.2 centimeters or 152 millimeter blade, so 6 inches, and it is 77 grams, which, again, that's going to be most of the weight of the entire robot. So yeah, we're gonna have some fun with this, as it turns out. Clover pattern is like the FT blade mount. Okay. Right, okay. That's interesting. I will have to have a look offline while I'm not streaming, because I don't have a setup in my OBS software to take you on my journey of looking through web pages. And also I feel like that's kind of a bit of a waste of time on camera. I will look into that on my own after this stream. But at the moment, this kind of very rough thing that I've done here has made me confident enough that I'm not going to need to like print a kind of placeholder or something, that hole is going to be about the right size for my 5mm bolt hole here. So, okay, we're going to go back to Tinkercad now. Not Tinkercad, 123D Design. Here we go. And I'll catch you up a little bit on what I was doing before I actually pushed the go live button, because yikes. Anyway, let's take a look. So this is currently where the design is sitting. This big red section at the top is the area that the blade itself is going to carve out. This is a 6-inch sphere, or 152 millimeter. Sorry, not sphere. Cylinder. That's what I'm going for. Wow. Okay. Yes, streaming may have been an interesting idea this evening. Anyway, then we have the motor that I mentioned before. Now, one of the things I'm going to quickly run through, because I did actually try and do this on camera and then messed up my cameraing, is I'm going to go back to the desk cam and I'm going to show you how I got the bolt hole patination in the bottom here, because it's actually quite easy to do. Now, what I'm going to do before we do that is I'm going to take a quick copy of this, and we're going to move it over, and I'm going to delete the bolt hole patination off the bottom, and we're going to redo it together, because I have a method that works for me. I don't know if it's a correct method. It seems to do okay, and it might help some of you out there with your CADing in the future. Whoops, don't do that. We're going to go down. I think this is going to be 7mm. Yeah, cool. Right, so we've got a blank face on the bottom. You missed fighting me in the January meet of ARC. Building a second version of the bot and looking forward to coming for more events. Oh, cool. Yeah, it'd be good to see you at an ARC event. How did you go in the ARC event? Obviously, I missed that one because of featherweight fighting, which is unfortunate that they landed on the same weekend. Thankfully, the next set of featherweight fights are not on the same weekend as ARC, so that's good. I get to do both. Yay! 5mm bolt and shaft would go through fine, as the bore of the blade mount is 4mm, so 5mm will fit in space just fine. Awesome. Perfect. That is exactly what I wanted to hear. All right, let's actually get the bolt hole patination going on this, this thing here. So, how we do that? Let's go back to the desk. So, to do this, I'm going to zoom us down onto the motor and get my camera to actually focus up. And then I'm going to grab some bolts. Now, normally with this, you would need to work out what size bolts they are, but I know now that these are 2mm bolts because I did this earlier. So, bolts. So I'm taking a 2mm bolt, which is what this is, jamming it into this here. One into each side. So I've now got 2 bolts, and I'm leaving them stuck out on purpose. I then grab my calipers wherever I put those. Here they are. And I'm going to first measure my bolts. So my bolt is a touch under 2 millimeters, and that's about right. Bolts never are exactly, like an M2 bolt is never exactly 2 millimeters because of thread pitching and all that kind of stuff and clearance and yada yada. So they're just a touch under 2 millimeters. So if I then measure the outside, measure the outside, so grabbing in there, we get 13.5. Now, again, my 2mm bolts aren't quite the right size, or they aren't quite 2 millimeters, so that means these are about 14mm edge to edge here. And that means that the inner distance should be 10mm because you take off 4 millimeters. Yep, so there we go, 10mm. And that means the center to center point is 12mm. If I get my calipers to roughly 12mm, that should be roughly center to center, but of course, trying to line that up by hand is just rubbish and ridiculous, and you can't really do it. So yeah, by measuring the outside and the inside, you should get a measurement or an idea of what that bolt spacing is. And then once you've done that, you take that information back into CAD, which, here we go, back into CAD. We make a cylinder which is 2mm. We snap that to the metal of our brushless motor. We then move it out 6mm, which is half of the diameter. The center to center diameter we just measured. And then we simply circular pattern that. So we grab hold of it, we say circular pattern by this axis, and then make 4 of them. And that is the bolt hole patterning for this motor. That's it. Done and dusted. It's literally that easy. And again, this works for me. It may not be the professional CAD way of doing this, but it is what works for me. The other thing I will say here is that while this bolt patterning is usually the hardest part, the thing that I always forget to do is leave an extra hole here. Now, the reason you need that, again, we're going back to the desk. So the reason you need an extra hole is for our center point in here. The back of the shaft, especially on, well, not this motor, because this motor has been designed so that the shaft doesn't actually stick out that much. But if you look at like an 1806, the shaft of the motor sticks out a great deal, and it also has a circlip on it. And that circlip spins with the motor, which means it's spinning at very, very high speed. So you need clearance around that circlip. Otherwise, it's going to be rubbing against your chassis and creating friction and slowing your motor down and putting a lot of sort of energy into your motor. So you always need to make sure you've got a hole which has spacing for the shaft as well. So if we go back into here, I'm just going to put in, I know that my shaft is 4mm, so we're just going to put in, whoops, that's way too big, that's 4mm radius, that's not what I want. I want 2mm radius for a 4mm shaft. Put that in there, and then I could merge all that together and shorten my bolts down and stuff, and you'd end up with the motor that I made before I actually went live. So, yes, there we go. Any word on when Robot Havoc will happen? Yes, Robot Havoc 6 will happen in August. So it is part of Science Alive. It always is part of Science Alive. And I am going to just double check here real quick when Science Alive is this year. Science Live 2013. It is the 5th and 6th of August is Science Alive. So that means that Robot Havoc will be on at Science Alive at the 5th and 6th of August this year. I don't really know much more about it other than that is what the current go is with that. Also, nothing is fully locked in yet, so, you know, don't take my word as like absolute gospel, but that's when Science Alive is happening this year, so that is the likely time for Robot Havoc to happen again. Mini hijinks. Kind of. I've got the hijinks bar coming in, however, I think making it into an undercutter is going to be exceptionally difficult. So we're not going to do that. We're actually going to make it an overcutter, which is what this CAD currently shows. Yeah, that's where we're going to try and go with this design, mostly because it's such a large blade. Like, you can see that this is a 6-inch blade. Trying to get the wheels out the other side of it anywhere is just so much size and so much space that, yeah, like, it's going to be too big to try and do anything like that. So yeah, overhead spinner it is instead. And in this case, I have currently got, these are the N10 motors. That is our brushless motor. There will be another N10 over this side as well. And I'm currently thinking about using PCB material for the base plate of the design here, because I've been messing around with using that as weapons very recently, and I'm thinking that as it works for weapons, it should work as a thin, light base plate material for a robot that needs to be as light as I can possibly get it. Any process on Zap being built, or are you focusing on perfecting the Beetle version? I am focusing on perfecting the Beetle version. The last event that we went to, or I took the Beetle version 2, I took it without weapons, and it performed way better, which honestly was a bit, like, it's exciting and disappointing all at the same time. It's exciting because I got the thing working finally, and it actually, you know, spun up and it melted and it hit people hard and it threw itself across the arena. It was great. That was a lot of fun. But there wasn't that much changed between it and the old version with the weapons, other than removal of the weapons. So the big thing that got changed was the removal of the weapons, which means that removing those weapons increased its performance, which is real sad because I want the weapons to work really, really badly, but they just didn't, or they just haven't been so far. There's a couple of things that I'm working on in the background right now, trying to get some stuff together so that I can work on the Beetle more safely. The biggest problem right now is I can't really spin it up here in my house with the weapons attached in any way, because it's just crazy dangerous to try and do that. So I'm working on making some stuff that's going to make that whole process better and easier and safer, so that I can test the Melty in a safe, controlled space with plenty of time, and I can, like, take weapons on and put weapons off, like, you know, put weapons on, take weapons off, mess around with everything, and just try and work out what variables help with melting and what variables hinder melting, and then try and find a good balance of the two. I also have had a very, very wild idea for fixing a couple of the issues that I had with the weapons. And I've just got some laser cut parts back in for that, and it's going to be insane. But I don't really want to talk too much about that yet, because that's a surprise that we'll get to later on. How will the super glue bicarb soda do as armor for a chassis? That is an interesting question. I mean, super glue and bicarb soda does create some kind of, like, plastic polymer of some form, but I don't know how effective that would be. Yeah, I don't know. I don't know the material properties of the plastic material that is created by super glue and bicarb soda. I mean, I've used it as a quick fix tool before to try and, like, get some things working and, you know, stick some stuff together fast, but I've never really, like, tried to put load on it or, like, have it impacted. It'd be an interesting one to try. I've seen people try and, like, molded dice from bicarb soda and super glue, and I know that layer adhesion is kind of a difficult thing to get right, so I feel like you're never going to get a perfect brick of material that would be useful as, like, an armor panel, for example. For the Zap Beetle, what if towards the outer edge you had a stylus that could help provide sensor data? Yeah, I mean, that is one of the other things that I'm looking at. Is currently I've been what's called dead reckoning. I've been using the speed of the wheels to determine how fast the Melty is and how fast it's spinning and stuff. But that isn't the greatest solution for melting. I do want to add more sensors and stuff. And I do want to do some calibration routines. So you can do stuff like have an IR beacon and use that to calibrate your Dead Reckoning. And you could then, like, you could do that as one spin up and then remove all the IR stuff so you don't need to run an IR beacon in the arena. But just the fact that you've calibrated it off the IR beacon means that the whole thing is going to be way better and just melty better from there. So that type of stuff is stuff that I really want to get done, but again, I haven't had a safe space to test the melty effectively. So again, it's a thing that I'm working on, and within the next couple of weeks, we will have a video up on what I'm doing to make sure that I am safe personally when I'm testing the melty, and also my house is safe, because I don't want a melty to explode on its own and just like put a weapon blade through a window or something, because yikes, that would be a mess, and I do not want to have to deal with that at all. Yes. Anyway, let's crack on with a little bit of design work here. So this is our current setup and design. Oh, my desk cam has just died. Okay, we're going to be CAD only from this point onwards, unfortunately. Yeah, if I had turned the streaming system on correctly this evening, we probably could have had more time on that camera, but I didn't, so we are where we are. So anyway, we have a little box here, or a little PCB stand-in base plate that is currently 51 mil long and 82 mil wide, which is good. I've got this as a party here, and whoop, my camera doesn't like to focus on that with the background exclusion that I've got. And it is bigger than this by far, and it also, yeah, it ran like a 25-gram weapon. So we don't want to be anywhere near the size of this as a party. We want to be as small and compact and tiny as we possibly can be. Now, to aid in that, what I am thinking is I'm going to build an ESC into the base plate. So rather than use DF robot motors or use a Malinky Nano or anything, I'm going to build my own ESC directly into the robot's base plate, and also run all of the wiring through the robot's base plate too. And even with all of that, I still might need to put speed holes in it, just because, yeah, it's 1.6 mil thick of fiberglass. It's going to add a little bit of weight. I mean, in fact, I do have a board here, a PCB here, that I can put down and just weigh really quick. It's not quite the same size. All right, that's 8 grams. That's my power distribution PCB. Now that's 8 grams with a lot of copper in it, because I had to put a lot of copper in these so that they survive distributing power. That's 65 wide by 33 long. Okay. That's 9 grams for something that is smaller than this. Smaller in both dimensions than this. Like, that's... Our chassis needs to be about... where are we? I can't get that to work on camera. Yeah, so our chassis is going to need to be bigger than that. Maybe the PCB substrate needs to have holes in it. It may be a case that we need to, like, run some speed holes back here where we're going to be mounting the electronics, and then just run, like, tape underneath or something. Or tape both sides, like a tape sandwich, to block those holes and run way less weight. But it will probably rely on what we actually do with the SMD componentry that I want to put on this board. Anyway, we should keep going with this. We're going to put down our other motor literally by mirroring it into place. So if we go 10 mil, we're then going to mirror the whole motor by that plane. Done. All right. So at the moment, we currently have our weapon blade, well, our PCB sitting directly on the ground. That's not gonna work. Basically, We need the whole system to lift, and we probably need, at a bare minimum, 2 mil clearance just for bolt heads and stuff. So in fact, what I'm going to do is I'm going to do 2.5 mil clearance, because that's going to give us, hopefully, enough clearance to sit everything in underneath. Now, the question here is, I need to actually put a floor down, so we're going to put down a block, and then push that down into the floor, or to the floor level, and extend it. Whoops. That's not what I wanted to do. That was the wrong tool. This is the right tool. Bam. Okay. So now what I want to do is I want to look at shaft to floor. That is 7.8. And shaft to weapon, that is 9.5. Okay, so we've got like 1.5 mil between our wheel and our weapon. Yikes, that is probably going to be a little bit too close. So let's see, we're 2.7 high. So let's actually grab all of that again. I need the weapon and I don't want the floor. Let's push that down by, I think, 0.7. We're going to do 0.5. Cool. Okay, so that is going to give us a different distance to the ground. 7.3. 9.5 still. Cool. All right. 7.3. What is the radius of this? The radius of this is 1.5. 8.8. Okay. So let's get a wheel catted, or a rough wheel catted. This is going to be 8.8. We're probably going to do 12 mil. Actually, 6 mil is all we're going to need. So this is going to have to be a custom wheel for sure. Nobody makes a wheel this small, because these wheels are tiny. They are 17 mil tall. Actually, that's a good point. What's our blade height? Our blade height above the ground is just shy of 20 mil. So, yeah, that's not too bad. I'm going to take that. I'm going to say that's okay. That's fairly low to the ground. I think we can deal with that. So, let's get our wheel kind of more in situ here. That's a bit better. Actually, it's probably going to be out further. Cool. And then let's look at that to that. That's 2 mil now. Oh boy. 2 mil deflection. And it will clip the wheel. That's honestly not a lot of deflection for a bar this size. Let's actually take a look. How far out is that? 2 mil deflection. So it's 2 mil this way at like 32 distance. That's possible. We could clip our own wheels here if we're not careful. And I'm going to have to be really, really careful molding and making these, because they need to be exactly on center. Otherwise, yeah, if they're 2 mil out, they're going to clip the wheel when they rotate round, unfortunately. Clip the weapon when they rotate round. So the plan is to have the PCB as part of the chassis. Yes, 100%. It is light, strong material that's really thin. And I think doing that is going to be way better than a 3D print in a lot of ways. Because, yeah, a 3D print... So this is 1.6 mil here. A 3D print that is 1.6 mil would be lighter than this, but it would also break immediately on the first hit. There is no way even an ABS print at 1.6 mil thick survives an impact with somebody else. So yeah, we got to do what we got to do, and in this case, that is a PCB base plate. I would say like a carbon fiber would probably be better, but I can get PCBs done quickly and easily, and machining carbon fiber is nasty, nasty business. You need like respirators and water filtration, or like water running on the part at all times, and even then you need to be really, really careful about like where all the dust is, and it's just, if you can avoid doing it, avoid doing it. That's why I use like carbon fiber drone arms and things, because they are, yeah, they are like the better. Like they're a pre-made thing. You don't need to cut carbon fiber yourself. Could you make the bar thinner where it passes over the wheels? I mean, maybe, but again, it is just the hijinks bar. Like I'm buying this weapon bar, literally this one. So to make that thinner, I would basically have to like make up a little rig where I was spinning the hijinks bar and then push a Dremel into the underside of it at just the right spot to route out some clearance. Oh, I mean, theoretically possible, difficult, very, very difficult. But yeah, maybe doable. It might also help with the fact that, again, this is a 77-gram bar. That's a lot of weight to be putting into an Antweight's weapon system. So yeah. But again, you never know till you try. And I'm pretty sure I've seen somebody put an 80-gram weapon in an ant before. So it's possible. People have done it. I just want to be a people at this point. Cool. So, oh yeah, that's the other thing I need to consider. I need to consider motor mounting. At this point, we don't have a lot of space for a motor mount in any way. It will remove the paint job as well, which would be a shame. Yes. Yes, it would. The hijinks bars are very, very pretty. I love them. That is partly why I'm doing this build in the first place. Well, actually, it's the entire reason I'm doing this build in the first place, is I saw the hijinks bar online and went, I gotta have one of those. That's just too cool. I just need one of those. And here we are. So, yes. Super glue, someone says, for the motor mounting. Yeah, I mean, that would be cool. Let's see if I can get my camera going just for a second, because I did actually do a test just before that I think you will be interested in if I can... no, it's not going to work for me. Come on. Let me just... Give me half a second, see if I can get this to work. Let's see if this... Nope, okay. The camera has decided... Yeah, camera has decided no, unfortunately. So we'll go back to CAD. Yeah, could definitely cable tie the motor mounts. So what I was going to show you is that this particular PCB, two of those holes have solder in them right now. That is because a while back I saw somebody solder motors to a PCB to keep them in place. And I was like, that's a great idea. I want to try and replicate that. So I just took one of my power distribution PCBs for featherweights and I tried to solder a motor directly to it, and it held for like half a second. My first attempt, I just like waggled the PCB around and the motor fell off. The second attempt survived the waggle test. The second I brought it to another room and dropped it on the desk, though, the motor immediately popped off. So I was like, all right, well, that's not a way that I can do this. Super glue is an interesting idea. Cable tie is also an interesting idea. I'm not sure I would trust cable ties on their own. Cable ties, like, with something else, I would maybe trust. Like, maybe some sidewalls already and then a cable tie could work. I mean, the other thing, too, is, as I can now show you, we literally have 2 mil space between the bottom of the PCB and the floor to have everything work in situ. So the cable tie needs to be real, real thin and not bend all that much at the edges to have it work. I mean, again, possible. I might even try cable tie and super glue. That could actually do the job for us here, maybe. I do probably want to print something into this chassis, though, so that I know where to seat the motor. I think that's going to be a good idea. because I do kind of want that knowledge of like, cool, this is exactly where these things need to sit. Now, the other thing I want to do right now is I want to actually start looking at walls on this thing. So I'm going to hide the weapon for a second, and I think we're just going to start looking at the wall spacing. So I'm going to cheat the walls a little bit here. Actually, let's not do it that way. I think I want to shape this out a little bit too, because a square is kind of boring. So we're going to throw some chamfers on the edges, just on these back corners. Again, hoping like that we have enough space for everything. But also, big old chamfers on the corner means less material for the PCB, which means a lighter PCB, and we like that. That is a very, very good idea. The other thing we want to do, we're going to set up... All right, so radius... actually, we'll do that later. Let's get a set of walls going. And the way I'm going to do this is really, really easy. I'm literally going to copy my base plate. In fact, I'm going to take a second copy of my base plate and leave that all the way over to one side. And then we're going to extrude our base plate to be the height of everything else. Actually, we're probably going to need, yes, of course, it's a weird angle or a weird number. Cool, so that's the height of our motors. That's all the space I want in this thing. I want it just to have the height of the motors. That's going to mean squeezing in battery, ESC, receiver, everything's going to be a tight jam into this. So we probably need a quite solid top plate so that the electronics don't bulge out of it. Will this have feeder wedgelets if possible? I don't know. It will be very dependent on weight. Because again, like, I mean, I also want the reach to be as large as possible. And if I show solids, like, this has got a pretty decent reach at this point in time. But if we put feeder wedges on it, it kind of reduces the reach down a little bit. Also, they're going to be heavy. Like, they're going to add weight of some form. So I don't know. We'll see. I think it will be a case of we'll get everything else together and done. And then if I've got enough weight for feeder wedges, I will reprint a chassis that I can mount some like floppy forks to the front of, I think is going to be the go. I don't think rigidly printed wedges is really what I want to go for with this design. Mostly because I want this thing to sit upright like this. I don't really want the blade to angle down. I've done that before with like very, very obvious and a little obvious. And they get really difficult to drive really quickly. So keeping the blade horizontal, definitely what we want at this point in time. Just join the stream, no idea if it has a name. Just recommend glass cannon. Yeah, I mean, that would be appropriate, I would say. I'm not sure if I'm going to call it glass cannon. I mean, I am using a hijinks blade. I do like the idea of having like an homage to hijinks in some form. But I kind of, I'd want it to be a combination of things. So, like Annie, Are You Okay is a combination of like my love of pop culture names and Robert Cohen's crippling depression theme. I'd want the name of this robot to be Hijinks, but pop culture, if that makes any sense. So if you've got any names that you think fit that bill, please let me know. I am considering anything at this point in time, because I have not named the robot. So I've just sped through what I just did there, but literally I took the same shape as the base, I extruded it up to be the height that I wanted it to be. Whoops. And then I did a shell cut from it so that I've now just got walls and it's got its own base plate. But that's why I moved it across. I'm literally just going to punch that out now. And now we just have the walls. Exactly what I wanted. Well, close to. I mean, we've got some extra features we need to put in. Like these walls don't have holes for our motor or anything. And we definitely need holes for our motors to stick out of. Low jinx. Oh, I really like that. Mostly because, like, yes, lower weight class, but also, so high jinx, weapon mounted underneath, low jinx, weapon mounted on top. Just complete reversal. Brilliance. That is my forerunner right now. I'm not sure if it's going to stay that way. It's going to as I build the thing, I usually come up with names during a build process. So during CAD processes, they don't normally have names. In fact, all of my like file structure for all of my CAD design is done around weapon type rather than names of robots. So like the Annie Are You OK folder on my computer is just listed as Beetle Undercutter. It's not listed as an Annie Are You OK folder because I CAD'd her all the way up and then came up with her name during the build process as I was like putting bolts and stuff together. So if you want a pop culture link, get Jinxed. Yeah, okay. I mean, I think Low Jinx is still the forerunner at this point for me. But again, we'll see how we go. There will be a build video on whatever this robot ends up being called. By the way, we will get there in the near future. Because I want to build this and fight this, and you know we're streaming it right now, so yeah, we're definitely going to build this on camera and have some fun with it. Now, next thing I wanted to do was I wanted to put a shield around this boy here because we don't want anything touching the motor that is spinning it at ridiculously fast speed. So let's see, 10.5. Let's go. I think that should about do it. And what we're going to do is we're going to cheat this on here. And 16 mil down. Okay. Cool. 16 mil down. And then we actually want to push this down to the same height as... Oh. Perfect. So, that is going to make up our motor shroud. Mr. Bojangles? No, Mr. Bojangles is already a robot at ARC. I'm not going close to somebody else's name. We're going to leave that one well enough alone, I think. So, what I'm going to do, we're going to cut the motor shroud down. Where's my subtract tool? There it is. Bam, bam, bam. Then if I move this out of the way, like so, we've now got a space in there. I'm going to push this back 1 more mil, and that is our motor shroud, mostly done. So let's go into here. Cool. So that gives us our, it's 1 mil spacing around the motor, which... Yikes, that's not a lot. Yeah. It's really, really not a lot. But, I mean, it's better than nothing. And we could push this out a little bit. In fact, you know what? This is feeling a bit sketch. So we're going to push this out by an extra mil just to give that motor just that little bit more space. Now, the next thing to do is to cut all of this so that... yeah. Now, which way do I want to do this? This is interesting. Because we can either leave this as a hole in the front, so we have a front, like a flat front plate, or we can build this in. Okay, I think I know what I'm going to do. I am going to make the circle on the front, I reckon. You could mill some CMC, 2 mil carbon fiber for the base plate, and add 1 mil recesses for the motors and zip tie them in. It would work, but it's a terrible idea. Yeah, I could. I have already mentioned, so this currently, the base plate is 1.6 mil because I'm going to use a PCB. As mentioned, I think before in the stream, carbon fiber and machining carbon fiber is dangerous and messy, and if you're not set up for it, it's just not a good idea. I am not set up for it. I don't even have a CNC in my house. I'd need to go to a makerspace. And then I'm CNCing carbon fiber in a public setting, which, I don't know, that just feels dodgy to me in a lot of ways. So Yeah, I'm not gonna mill carbon fiber myself. I'm gonna use PCB material, which does mean that yeah, CNCing slots into the PCB is going to be very, very difficult. So yeah, setting them up and super gluing and zip tying them in, I think is going to be the way to go. Yeah, it's going to be interesting. I've only got two M10 motors, so if I super glue them in, that's the chassis we've got from that point on, I guess. Because yeah, we're going to be in trouble if they break, basically. Right, so I'm going to do a little quick trick here. What I'm going to do is I want to cut out just this section in the middle of this ring. So the way I'm going to do that is I'm going to subtract. So I'm going to grab this outer wall, and from that outer wall, I'm going to subtract one of the motor shields, which means that now this wall looks a little bit different. If I move this out of the way, you can see I've now got two little slots in this wall, which you might be like, well, that's not really going to do too much. But we are going to then be able to grab just the face of that middle section and entirely remove it. Bam. Just like that. And now we can put this back in place, like so. And if we merge these two pieces, then that will become one solid part and just work from that point on exactly the way we want it to. Now, we had a small gap. How much gap do we have between here and here? 4 mil. Yikes. Because if we want to get like a 3 mil bolt in there, that's going to be kind of difficult. Is there going to be enough weight for top armor, or do I have another idea from preventing the wiring from getting sucked into the weapon? There has to be top armor. Yes, I want to do everything I can to get top armor on this design, because you're right. Otherwise, without top armor, everything's going to get sucked up into the weapon. Now, if I put the weapon back on, you have from here to there is 6 millimeters. So I've got 6 mil between the top of my design currently and the weapon. So I've got enough space to put in like 2 mil HDPE or a 1.6 mil piece of PCB. Like I might just clamp another base PCB to the top and bolt them together that way. Maybe that's always an option for like a lid design. Yeah, I don't know. But yes, definitely a lid. Yes, hello in chat there. Yeah, we can't not have a lid. I mean, a little obvious got away with kind of dodgy lids because I was pushing all the electronics to the back out of the path of the weapon, but as you can see in this particular design, nothing is out of the path of the weapon. It is all path of the weapon. So yeah, we need to do something to make sure that they don't get sucked up into it and just lose the fight by self-annihilation, basically. Yeah, cool. So let's get rid of this weapon again. We don't really need that for the moment. That's the wrong button. That's the right button. Because the next thing we want to do is add holes for our motors, which again, we're just going to do by subtracting. So I'm going to grab that, and subtract. And now our motors have space in our walls. Now, this is the other thing that's happening right now, is that these walls are ridiculously thin. They are 1 mil? Yes. 1 mil thick walls. They are not going to survive anything. Like, they're one hit to these and they are going to just be eradicated. So I don't really know what I want to do about that, because thickening them up will add just way more weight, and realistically, like, it should be pretty well protected underneath the giant spinning disc on top. So unless somebody's really, really low, they're not going to hit us, hopefully. Fingers crossed. Like, it's going to be quite the challenge to hit us. I mean, yeah, my old weapon, the pink one, is 103 millimeters. And this new weapon is 152, so it has like 25 mil of extra reach that even this blade didn't have. So we should be contacting first. As long as something is high enough up for us to hit, we should be contacting first. Theoretically. I guess, though, from the back, we might be susceptible to a hit. So maybe we buff the back and not anything else? That could be a doable solution here. Let's take a look. If we just, like, give the back a little bit of extra. I mean, that's only 2 mil, but that should be okay. I mean, if I print this wall out of, like, TPU, it should be totally fine. That's an idea. TPU would be a good one. I was thinking about maybe trying to CNC this out of HDPE, but I think that even 1 mil HDPE is going to be a bit of a stretch here. Oh, and it's 10 mil thick. Perfect. I have 10 mil stock. I could very, very easily CNC this if that's the route I want to go. Interesting, interesting. The only thing I've just thought about is that having cut the access point for the motors, I've made 2 separate sections of wall. Actually, I've made 3 separate sections of wall, although these will get joined in with the motor shroud, so they will go back to being one when we get to that point. But that does mean that we've got 2 separate sections. It's actually probably not a bad thing, because if I'm seeing this out of a billet, then I can cut the shape separately, and this middle section here is not wasted material, basically. Yeah, that'd be cool. We could definitely do something along those lines. I don't really know how I want to approach that, because yeah, TPU or HDPE, both of which should survive pretty well. Although, yeah, again, 1 mil thick, it's probably not great. And as I think I mentioned, as was mentioned earlier in the stream, if I wanted to do like forks on the front, I mean, there'd need to be long, long forks to get anywhere important out here. But if I want to do that, I need to have mount points up the front here. Yeah, so I guess that means it needs to be printed out of TPU, probably. I think TPU is heavier than HDPE, though. Material selection is always a problem. Yes. Anyway, let's keep cracking on with this design. Now, the other thing I want to do here is we want to... I'm going to get rid of this for the moment. We want to have a look at cutting our holes for our motor. First thing I'm going to do is turn this 45 degrees, because that means that our wire comes out this way, down into the robot, and not out towards either of the motors, because that means, yeah, we don't need to worry about any of that. And then I'm going to want to effectively put a gap. Oh, that's not what I wanted to do. That is what I wanted to do. I want to put a gap in... Come on, do the right thing this time. Thank you. Yeah, I want to put a small hole in underneath here so that the wires for the brushless motor can come straight out into the electronics bay, and also keep this wall up around the brushless motor, stopping it from, you know, wrecking everything. Because it's going to be spinning very, very quickly. So we're going to quickly grab this and spin it to that point there, and then we need to set it down on the ground, ball mill down. I'm gonna hide the walls for a minute because it's just gonna help sort this out. Doesn't really need to be that big, can probably be about that big. This, as you can fairly well see, is just a lot of guesstimation. It doesn't need to be very accurate. Literally all it is just to feed wires through. So as long as it's, large enough to get the wires through, it will serve purpose. I'm just going to make it just that touch bigger. Yikes, that is quite big. So if we then subtract that from there, we've got a nice little hole that allows us to feed that wire in. Beautiful. What a coincidence, just watching a video of Annie, are you okay, battling about 3 seconds ago. Oh, cool. Which video was that one? I mean, Annie has had a lot of battles in her very long career as a combat robot. She performed pretty well. On the whole, she performed pretty well. There was a period there where I was using her as a test platform for every weird and wonderful drive idea I've ever had, and during that time, she didn't perform particularly well. But, you know, that is kind of what happens when you, like, sort stuff out in that way, or when you're experimenting with weird concepts and design ideas in that kind of way. Right, yes, we are actually sitting pretty good at the moment. We have got things mostly together. What I'm going to do, I'm going to see if I can just quickly find a battery here. Now, this screen doesn't show up. You can see me moving my mouse, but you can't actually see what it is that I am looking at here. Oh, well. All I'm doing is looking through all of my files for a particular battery that I've built in the past, and maybe I didn't separate it out from other designs. Let's take a look. Nope, that's not got one in it. You're gonna have to give me half a second here as I try and find a thing that I thought I had already saved out, and apparently it's just in a design right now. It will be in one of the drums, because in the early days of building drums, I was making sure I was catting literally everything. Oh, okay. No, it is not in any of those. That is a problem, because I don't actually have a battery to hand. I have other things to hand, like other robot chassis and stuff. Oh, actually, no, I do have a battery to hand. The mess on my desk is actually helping us out in this particular instance. So we're going to cancel out of that menu, and I'm going to very quickly remeasure my battery setup here. It is 34 long. Let's get a box out. 34 long by 20 wide. Cool. 20 wide exactly. And height of 11. Oh, that's going to be a problem. Yeah, we may end up having to use not this. So this battery here that I've just put into this design is one of the very, very common batteries that people use in ants. It is the 180 milliamp hour battery. Which, these are great, they work really, really well, but they are quite big. And as you can see, here is massive. Compared to the space that I have in this current design, it's real big. I'm also just going to quickly change the color of that so that I know what it is. Tinge it red a little bit. Cool, there we go. That's our battery, or one of our battery options. Whoops, that's not what I wanted to do. Don't do that. That is one of our battery options. I can always use my custom 2S battery that I built a very long while ago now that is still kicking around and still working. And for this particular design, I might need to. Not only is it a lot smaller than this battery and a lot thinner than this battery, it also weighs a lot less too. It saves me 5 grams, I think, from memory, every time I swap out batteries to the old school or to the custom battery I designed. So when we're talking about trying to fit a 77 gram blade in a 150 gram robot, every gram's going to count. Yeah. All right, so I think we're kind of looking okay on this one at the moment. Now, let me just. It's actually getting kind of late here. I was planning to stream about this long, but for those of you who missed it at the very start of this stream, I messed up on the start of the stream. I was streaming for like 10 minutes or so, or more even, and I had not pushed the go live button. My OBS was running and it was streaming to YouTube, but YouTube was not outputting the stream to all of you. So I'm actually, yeah. I've streamed longer than I was planning to because of my mess up earlier in the day. Well, as in, I've streamed later into the evening. Wow. It is later at night here in Australia, so words are a thing that I am trying to do, and maybe succeeding? I don't know. We'll find out. Yes, but I think I'm actually probably going to get... I think I'm getting close to a stopping point here. I've CAD'd in the things that I had brought with me to CAD in. I have some design decisions to make. The glue and zip tie option from you guys out there, I think is a really good one, especially for keeping the form factor of this as low and thin as possible. Probably going to do a couple of practice runs at gluing motors down to a chassis because I have a feeling that it would be real easy to like mess up and glue into the gearbox accidentally. So definitely want to try that out and work on that a little bit. But I'm pretty happy with how this is sitting right now. I think, for the first time ever, need to sit down and CAD my receiver and my speed controller that I want in here. For those of you who missed it earlier, I am going to use a PCB as the base plate material. In fact, let's sit down. As the last guy said, use sandpaper to rough up the motor surface. Yeah, cool. I actually, when I tried to solder a motor to a PCB, I roughed up the surface with actually a set of files, like little tiny needle files. But it didn't help. Super glue is a better idea than solder is, for sure. I want to make this look kind of PCB-y. Yeah, there we go. Cool. So that down there is going to be a PCB. Depending on how heavy that is, we will probably end up also PCBing the lid. Like right, whoop, that's too tall. We don't want that. It's probably about 4 mil too tall, I reckon. Yeah, sorry, 0.4 mil too tall. We can just nope. -0.4 to get that touching. So that's kind of what we want to do. I mean, you can see here that the battery is currently inside the PCB, which is not great. We do have some space, like we've still, even from here, we've got 4.4 mil to the top. So we could bump this up an extra 2 mil. 1, 2, like that. That gives us plenty of space for a battery and everything. Just to kind of get space for all of the things in. Even that right there would give us space to sit in that bigger battery. Again, I'm not sure if I want the bigger battery. It is going to be a massive weight drain on this robot. And yeah, I mean, that's 3.4 mil. Like, you only lose a mil to allow for that extra battery. Maybe I do it anyway. Or at least design 2 outer walls, one that's the mil taller and one that's a mil thinner, so I can choose between the two as I go. Because obviously, every time you add space in any dimension to a robot, you are adding a lot of weight down because you have to suddenly stretch all of your walls to get things to work. I can imagine the vast amount of colors on the final product. Yeah, so I mean, the interesting thing here is that a lot of this is for stream. When I CAD for myself, I don't put a lot of colors down per se. In fact, I can show that off real quick. I need to very quickly save this out because otherwise this program is going to get real angry with me. And then we can flick through, as before we finish off tonight, I will flick through some of my other designs here and show you what I mean. I don't normally put too much color in my designs, mostly because, you know, they're for me, and I fairly well know what things usually are, but it is nice on a stream to have differentiators so that people could be like, hey, what's that yellow thing? And not have to try and, you know, guess an error, find some other way of referencing what pieces are on the screen. Was the Robot Havoc 5 video. Oh yeah, her last fights. Yeah, I really liked that video. And I really, yeah, she did really, really well at Robot Havoc 5. And that was actually why I retired her, is because I was having a lot of fun with her. I'd taken her back to the UK. She finished on top, basically. And I'm actually going to call this file, for the first time ever, this file is going to be called Lojinx, because I think, at this point, that is going to be the name of this robot as suggested by you out there. Alright, let's open. Actually, I'm going to give all of you a choice here. We're going to open an ant weight of some form. Do you want to see a drum spinner, a ring spinner, a wedge, or something else? Let me know. Let me know what you think you'd like to see of my 123D designs that I have done in the past. I have a lot of designs here, actually, as it turns out. I kind of forgot just how much I do actually CAD up. There's a lot of things that I CAD that don't ever go anywhere. There's a lot of robots that kind of get conceptualized and then stop at a conceptual point. Sometimes because they don't make any sense, or they're not going to make weight. Yeah. All right, you want a drum spinner. Okay, we can definitely do it. Well, let's do a drum spinner, then a ring spinner. Okay, now. Oh, the drum spinners are interesting. Yeah, okay, let's do this. So this here is what I'm talking about with me never coloring anything. This is, at one point, I was looking at redesigning my drums for my drum spinner. So these two here are plastic prints that then had pencil sharpener blades put in them. That's the same as this boy up here. He was a 3D print that had a pencil sharpener blade put in him. And then all of these other ones are actually like designs for laser cutting, or like prototype designs that are then moved over into Fusion and got laser cut to make my drum spinner up. Cool. So that's part of the drum. I mean, the reason I showed that rather than other things is because, like, the drum files themselves, this is back at a point where I wasn't splaying so much in my CAD designs. I was literally just like doing everything all in one go and jamming everything together in place. And it meant that everything, like, there's nothing. Oh, actually, there are some other little bits in here. You can see, like, a motor and drive wheels. And again, oh, this one's interesting. It does have color in it. Wouldn't be surprised if somebody says wedge. Well, I mean, technically, you have just said wedge. By saying that, you have said wedge. That is how that works. Yes. So, okay, this is the drum spinner, and there you go. This is a while back. This is Don't Need Roads, a very, very long time ago. Back when I was first starting to put brushless motors in things. This is also actually, this specific version of Don't Need Roads has a TPU frame or TPU armor and then a PLA or ABS chassis base in it. Which, this idea kind of worked and kind of didn't. I didn't really ever take that to full competition. Alright, so there was also a request for ring spinners. Let's take a look at some ring spinners. Alright. Now, let's see. I've got a bunch of ring spinners in here. So this was I think the most recent attempt at a ring spinner. This one actually got made and taken to Melbourne 2017, I reckon, 2016, 2017, somewhere around there. After a couple of years of having not built ring spinners at all, I took this particular version over to Melbourne. And this here, this is very, very apt for me for CAD designing things these days. I will, like, make a part up and I will, like, so this here is how the weapon teeth get mounted in. I, like, put down a block for the teeth, and rather than cut all of these things together, I copy all of that, moved it all the way over to here, and then did the merge and did the cut so that this is the final output piece. But also, if I'm like, cool, I actually want this, but with 5 teeth now, I can come in here, I can go like this, I can grab an axis, and I can do, 5 teeth. And that's really, really easy, but trying to, actually, we're just gonna not do that. But trying to, like, take this, cut these teeth back off of it, and back solve it is just really, really difficult. So somewhere along the way with my CAD designing, I remembered to, leave all of my designs in stages so that I can go back through stages. It's kind of like leaving yourself a timeline almost, or leaving myself a timeline. Like, and it probably was about the time I started using Fusion that I started doing this so that I could back solve through designs and make tweaks to specific things as we went. Full body drum spinner. I don't have one of those. I wish I had one of those. I don't have one of those. I've been toying with the idea in the back of my mind. Maybe it will happen sometime in the future. Not right now. Remember when you got the words Team Panic laser cut into a drum? Yes, I do. Yes, I do indeed. That was actually the same cut that I got those others that had, like, circles and stuff in them. That was the same laser cut job that I did. I just got all of them cut at the same time. It was really cool. That was those. Somebody wanted to see something else. All right, let's see something a little interesting. What have I got in here that is a little interesting that hasn't really been seen on video ever? Oh, that's an interesting one. Do I have a good copy of that? Triple point's not the one that we want. We don't want that one. Huh. My folder gave me a... oh, there it is. This is stupid. It was a very, very ridiculous idea that I had at one point. This file is called the Underlifter. It is a very Valkyrie-inspired undercutter, but instead of an undercutter, it has a servo. If I remove the lid here, it has a servo up front, and the weapon is this. It is a Minecraft pickaxe-inspired rotary lifter idea. This is one of the projects that, as mentioned, sometimes I mess around with an idea, I CAD it up fully, and then it doesn't go anywhere. This one actually got to the print stage. I printed this at one point, but I never made a video on it or anything because it never really performed. And it just, the build process, like putting it together by hand, I was like, this is just not going to do what I want it to do. It's not going to be an interesting design. It's not going to work in a significant way. You can see I've just, like, unhid some of the parts that are hid or were hid around the place, and you can see, like, early lifted designs. So the idea was to, scoop a robot from the side and get them off balance, basically. I don't know. This idea may work. It may have worked with a different setup. But, yeah, this particular setup, no. I think one of the big problems is that all of this surface area was going to touch the ground, and that was just going to make life really difficult for the drive system. So while the weapon itself might work, the drive on that would be just silly, basically. It's like a horizontal mammoth. That is an interesting point. It is kind of like a horizontal mammoth. Right, let's take a look at something else. So somebody said somebody's going to say wedge, so I'm going to show you a wedge anyway. I've got a ton of wedges in here because I mess around with wedges all the time. Oh, I didn't realize that was in here. What do we want to look at, actually? Yeah, let's look at this. So this here, again, is something that was never really seen on video. This is very, very, very early. This is actually even before I started my YouTube channel, and this never fought. This was my very, very first wedge that I bolted N20 motors to, and I didn't even have a top plate or armor or anything for it. It was literally just me sussing out radio gear and stuff. Like, I printed this shape, I bolted N20s to it, and I just got it moving, basically. The one thing you'll notice, though, out of this is that these motor mounts are the same as what I am still using to this day. I think, actually, the motor mounts I'm using currently are just slightly smaller just to give a little bit of press fit, but the shape and design is exactly the same as it was in 2015, 2014 era Ben Designs stuff. Have I got CAD for MacGuffin? Yeah, I've got CAD. You know what? Let's look at CAD for MacGuffin. I mean, I've got 123D Design CAD for MacGuffin, but I also have Fusion 360 CAD for MacGuffin. And MacGuffin, at this point in time, is probably never going to go anywhere. So let's take a look at CAD for MacGuffin. I'm probably never going to build MacGuffin, I don't think, because at this point, all of my stuff has shifted to the melty focus stuff. So MacGuffin was never a melty. It was always just a, like, 1-2 side puncher. Like, it was always supposed to, like, bang, 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 like this. It was never supposed to spin round. Yeah, so this here is the CAD for MacGuffin. I'm actually quite proud of this. You can't see my stuff here. I mean, you can see my timeline. My goodness, there's so much in here. But I am quite proud of this design. There's a lot of stuff in here that I really like. So you can actually, let's take all the armor off. So this is MacGuffin sans armor. And you can see it's a fairly slim design. It was all going to be done out of laser cut hardox. Everything was going to be shock mounted. These wheels in here are the same ones that Death Roll uses. They're a brushless hub motor. Yes, Death Roll uses 4. I was just going to use 2 because my focus was getting the weapons going. I wasn't really focused too much on pushing. But you can see how slim and compact I managed to get this design. There is barely any room on either side of the battery box, and I wanted some space there. A, because there are actually bolts that go through there, and B, because even the battery box was going to be shock mounted, so the batteries could move just a little bit, and that, allows them to not die in big hits, basically. You can also see some of this stuff is fairly mocked. So like the weapon motors got mocked up because I'd catted a lot of stuff and I was running out of time to put the application in. So some of the stuff like the weapon motors just got mocked up, and the belts and the drive pulleys and stuff just got mocked up. But yeah, the actual laser cut parts, I would probably need another, 20 minutes to an hour to get these ready for the laser cutter. There's just a few bits and pieces on them that would need to be like filleted and chamfered and tidied up a little bit to have them ready for the laser cutter. But also I would need to do like this plate here. You can see it doesn't have any holes in it, and it needs holes for mounting up the brushless motors, for example, and also mounting up the brushless drive controller, which is that box there. It's a double VESC, so that was going to run these two outer motors. And then there was another double VESC over here, which was going to run this. And then there was a single VESC here and a single VESC there, which were going to run the drive system. So MacGuffin is really, really compact for what it is. There's not really a lot more space I could have taken out of this. I could have maybe compressed it in that way, just a smidge. But yeah, I was pretty happy, in actual fact, with how MacGuffin ended up coming out of this whole process. It looked pretty good. I could probably build this, and at some point I might even go back to MacGuffin and build like a featherweight version of MacGuffin, or even a beta weight version of MacGuffin. I think would be pretty cool. But for now, MacGuffin is just not happening. Anyway, let's put an armor package back on, because I want to actually, I'll show you the armor package as well in a little bit more detail. So let's go into here, and let's take off the whole front wedge. So that is in Fusion 360, it's one body that I can just take on and off. In real life, it was going to be 2 laser cut panels, and each of those laser cut panels was going to have little holes in it. What are the dark gray boxes on the other side of the L next to the wheels on the other side of the weapon motors? You mean this in here? That in there, that little dark grey box next to the wheels on the other side of the weapon motors. Yeah, so this grey box here, that was the VESC for the drive system itself. So this grey box here is the double VESC for the weapon, and then this one was the VESC for the drive system. In fact, these are older, less powerful VESCs to run the drive than I was going to use to run the weapon system. The weapon system was going to be way more powerful than the drive was, kind of on purpose. But yeah, so as mentioned, this whole front wedge comes off. In real life, or to get this into real life, I would need to cut slits into here so that tabs would come through from all of these wedgelets out the back, or all of these pieces out the back, so that all of this could get welded together. And effectively what would happen is this gets welded, like all of these triangles were going to get welded to the back of each of these, and then they were going to get welded to the base and to the back here. And this back is the thing that gets bolted through into the robot with rubber spacers, so that the whole front edge of the robot like springs back, which means that A, it will touch the ground properly, and B, when it gets hit, it's not transferring all that force into the chassis, it's just, yeah, absorbing some of that, basically. However, this, again, not fully finished. There would need to be speed holes in under here. In fact, did we do that for the back armor? No, we didn't. Okay. That was bad of me. There was supposed to be speed holes in here that A, dropped the weight of this whole armor package that sits up front, but also allowed for like the welding torch to get in and weld these pieces, and also allowed you to get a wrench in and bolt the robot together and all of that kind of fun stuff. Because you'll notice too that all of this is really, really tight. There wasn't going to be like a lot of space in here, so I was trying to design with where do spanners go when you're trying to, put bolts in. And it mostly worked. I mean, you can see like this here, this is a switch that is blocking a bolt hole right now, which isn't great. There's not really a lot of other access points to that bolt hole. But then again, trying to put that switch elsewhere is going to be difficult. So it could have been moved out maybe to try and fix that issue, but we are running out of space quite quickly everywhere in MacGuffin, basically. And switches, weirdly, switches are the last thing I CAD every time, which does make the CAD process a little bit difficult, because sometimes you're like, oh, the only neat place for my switch is directly under a weapon, and I can't do that. So, yeah. What are my opinions on Project Liftoff and their advancements on multi-brain technology? To be honest, I have been very lax on keeping up with the melty community in the robot space. I haven't actually been watching that many of Project Liftoff's fights. I know from people talking about them that they are performing quite well. I really do need to go back through and watch a bunch of their fights that have been in Norwalk and stuff. I the thing I'll say about Project Liftoff at this point, the thing that I know about them that is their like distinction point from other melties that I know of, because I don't really know what their tech inside their melty is, and I'm very, very keen to have a look at like what brain they're using, what accelerometer they're using, all of that fun stuff, like how they're doing their heading tracking. I'm very keen to know that. But I know they're running cleats or, you know, like spiked wheels at Norwalk and chewing up the floor to get really, really good grip. And that's a really great idea that works at Norwalk, because Norwalk is fine with replacing the floors in their arenas every single event and that type of stuff. Unfortunately, I couldn't do that at ARC. I mean, I could maybe do it once, but then enough damage would be done to the floor, it would need to be replaced, and they wouldn't want to do that. The floor is kind of difficult to replace in the ARC arena, and it's also expensive. We are a community club running mostly on money from like people competing and also donations and stuff. So there's not a lot of money to like keep building and rebuilding things. So cleats, if they're not already banned, would be banned very, very quickly at ARC. So that type of thing I just can't imitate or mimic. But I can see the genius behind it. The fact that those cleats are going to get a lot of grip on the surface of the floor, and when they're accelerating and decelerating their motors, they're going to get more grip and probably more inertia behind that as well, which is probably what's like helping them melty as effectively as they do. So that's really, really cool, and I love that, but unfortunately I can't do it. And also, the other thing too, I guess, is that you all know, my plan with building melties is to get to BattleBots. So anything that I can't do at BattleBots, I'm not doing in smaller weight classes. Because I just, I want things to be as close to 1-to-1 as I can get them as I scale things. So putting cleats on the Beetle, I can't then put cleats on the BattleBot. Because cleats, like metal cleats on a metal floor, just ain't gonna work. Like, there's just no way. You will slip and not really go anywhere. So you need rubber tires to do that. The thing that I'm thinking about in terms of traction, now that I'm like on this weird traction tangent, is that a melty running magnets seems counterintuitive, but I think it would work. And I think it would work for the same reason that Claw Viper is currently working. That level of downforce is letting them do the things they want to do in terms of their motors moving and moving the robot precisely. So doing that with a melty would be really interesting. I think it would slow down your your robot's RPM, but I think it would mean that you'd get more traction on the floor, which means your translation is going to work way better. I just don't have a metal floor that I can test that theory on at all. So yeah, that one is just going to be a thing that hangs out in the back of my mind. If anybody who builds melties somehow finds the stream or is in chat, wants to put melty magnets on their melty, go ahead. Please tell me how it goes. I'd love to hear about it. And oh yeah, somebody in chat saying, wouldn't a bunch of magnets accomplish the same thing? Hey, great minds think alike. There you go. Yes. Yeah, I think so. I think that they would work. I'm not sure how much they would slow the rotation down. I mean, effectively what you're doing is like doubling the weight of the robot. Well, up to doubling or maybe more than doubling. Depending on how many magnets you put down, you could throw down a lot of stuff. And you impact your downforce, impact your weight of your robot, which means you're potentially impacting either your full speed of your melty rotation or your spin up time, because your motors have to work harder to get the robot up to speed. So it could be a problem, is all I'm going to say. I'm not sure how much, and the only real way to do that would be to test it. But again, I don't have access to any metal floored arenas, so I can't really do it, and I can't really test it. Yes, you can put magnets into wheels. I have seen people do that. I think it's a little bit risky, especially if you're building a robot where your wheels are further out, because if a magnet gets hit, it's just going to shatter and go everywhere. And that could mean that you get a tiny shard of magnet fly into your robot and get stuck somewhere you don't want it, like in a brushless motor. So that would be risky, I would say, but it should work, theoretically. Yeah. Right, so yes, the other question is, if you're going fast enough, are the magnets going to be inducting to the floor? Yes, they will. So I personally don't have any experience with this, but I have seen it happen. So a very long time ago, with the very first version of Very, Very Obvious, I went over to AVC in America, and I'm going to butcher his last name. Kevin McCloskey, he was there with a hobby weight. So it's a hobby weight Claw Viper, essentially. So he was there with a hobby weight version of what now is Claw Viper. So 12 kilos. But he was running enough magnets to make it 12 pounds. And he was running enough magnets to make it 40 pounds or something. Like something ridiculous. And then he had half of Tantrum's drive inside the robot. It was incredibly quick. It stuck itself to the floor like nobody's business, and it had induced currents. He would drive from one side of the box to the other in a flash, just the quickest thing I've ever seen, hit the sidewall, and two things would happen. There'd be a spark between the sidewall and his robot as that induced current got released, and the entire, featherweight-sized arena shifted just a little bit on its, feet on the ground. It was a wild machine to see. And so when the first version of Claw Viper got into BattleBots, I was like, oh, I know this guy, I know the robots that I know that robot that he's built, this robot looks very similar, this is going to be insane, and it's taken until this season for everybody else to see the kind of effectiveness that hobby weight had up at the Claw Viper scale. It's a very cool thing to use your drive as your entire weapon, I think. Well, obviously I think that. I'm building a multi-brain. But yes, specifically this style of hyper speed that Claw Viper gets out of itself is just ridiculous. I do have footage from AVC. There is a video up on this channel of me at AVC. It's just of my fights though. And I was fighting in the featherweight class and not the hobbyweight class. So I don't actually have any footage of his fights, unfortunately. I would love to. I really would. But then again, at the same time, also, I don't film other people's fights when I go to events because personally, I feel like I have ownership over my fights, right? Those fights are me. It's me putting myself out there. It's me showing what my robots can do and what my designs can do. So I feel like I have some ownership over that, and I have the right to release that publicly and show all of you what those fights look like. Somebody else's fights, I don't feel the same way with. It's their fight, it's their build, it's their design, so they should have say over if that gets published or not. Because while I love putting my fights out there and, having other people watch my fights, that is not what some people want out of this sport. So, they just want to go and fight and have fun, and however they perform stays at the event, and doesn't really travel much further than that. Yeah, but it seems if you build a very good melty with magnets, that is something that needs serious consideration. I would agree. And look, I think it's one of those things that if I ever manage to get a melty into BattleBots, I'm going to leave space in the design for magnets, because looking at how Claw Viper has gone with its magnets, I can't see how putting those in is going to be a massive detriment. I can see good things happening from putting magnets in underneath a melty. So I'd at least try it. I reckon, maybe second fight though. Maybe we fight first time without magnets and then put them on the second fight. I don't know. We'll see. Also, if I ever get into BattleBots in the future and you're coming back to this particular stream to be like, he's putting magnets on for the second fight, I'm not saying I'm going to do that. I have no idea. I mean, look, at this point, it's a very, very long shot for me to get into BattleBots, so I'm not making any solid concrete plans at all. Magnets near the center to minimize induction. So, yes, yeah, because putting the magnets closer to the center means that they're rotating a smaller distance per rotation, which means they're rotating slower than if you put them all the way out on the edge, which does effectively mean lower induction should be applied. But that also begs the question, like if we just, again, this MacGuffin was never and will never be a melty, but if we just imagine MacGuffin being a melty for half a second, if you put the magnet right in the center, like just one big honking magnet right in the center, that would be the least inductive of anywhere on the robot to put the magnet, because it's only going to get induction out of its own diameter, which isn't going to be that huge. So that might be the place to put a magnet on a melty, is slap bang in the middle. I mean, it does mean that, yeah, you're putting, effective mass into the middle, which, as you're a spinning weapon, you want to put all the mass as far out as you can. Yeah, I mean, that'd be something to play around with, I think, because further out, you're going to induce more current, which I don't know if that's a good thing or a bad thing. Like, if you discharge that in the box, it's probably a bad thing. But if you don't, it might be okay. So magnets further out means heavier further out, which means hitting harder, but inducing more current. Magnet in the middle means hitting less hard, but inducing less current. So, yeah. I think, it's something to think about. And I might even, for the next application to BattleBots, put magnet holes in the bottom of the robot, just in case, Putting the magnet in the center gives it less chance of high-siding the robot when it gets bent. Yeah, that's a very, very good point too, is that, yeah, jamming it up in the middle there is going to make it so that it's harder for the robot to get stuck on it. I mean, I think bending is less of an issue than, it collecting debris. And yeah, it being in the middle is certainly going to make it less likely to collect debris because, the robot's spinning around at high speed. Anything that it's going to come in contact with is going to touch a wheel before it gets anywhere near the center of the robot. So, that's probably a good idea for anti-high-sidedness, high-sidingness. But yeah, anyway, that's MacGuffin there. Fairly stripped down to its bare componentry. Which, yeah, I should actually at some point do a stream where we go through some of the other designs, because, yeah, it's interesting how much goes into these particular, especially heavyweight designs, and yeah, all of that kind of fun stuff. I mean, let's see, is my render stuff still active? It is, but the rendering gallery doesn't seem to have anything in it anymore. Oh, it does, but you can't see that on stream. Okay, that's annoying. It doesn't actually show up the rendering. But so this, I think I will just point this out real quick. So to compete at BattleBots, to apply to compete at BattleBots even, you need, well, I would suggest getting an idea of how the rendering software works in Fusion 360. BattleBots want a lot of images of your robot. They want full layout, so they want a 45 degree, a top down, a front on, a side on, yada yada yada. They want beauty shots of your CAD. They then want a shot that you then like highlight to be like, cool, here is where the batteries sit, here is where the switches are, here is what these are. They then want another one that's like, cool, this is all going to be hardox, this is going to be aluminium, or whatever's going to be whatever materials. They want them all listed down. So taking good shots and renders of your designs is very, very important for the application process to BattleBots. Because yeah, taking screenshots of this design screen isn't really good enough as far as I'm aware. I mean, again, I'm a person who has been rejected 3 times. I am in no way an authority on what the application committee want out of a robot. In fact, if anything, I'm probably more of an authority on what they don't want out of a robot. Speaking of, though, I think the final thing I want to do before going to bed, because it is actually getting quite late here, is let's take a look at Bolt. Because I quite like Bolt. There's a soft spot in my heart. That is the wrong Bolt. Despite being called Bolt Master, that is not the right Bolt. Because that is a very empty Bolt right there. The correct version of Bolt. Yeah, here we go. This is the correct version of Bolt. This has got so many components in it that you can't see, unfortunately. Let's just start turning some stuff back on. Oh, also, yes, this is the version of Bolt where the weapon blade and stuff got pivoted back out of line with everything. All right. Yeah, so this is the other thing. These are all shock mounts, which, those shock mounts have been pivoted. That's very, very odd. I don't really know why that's happened. They should be flush between these 2 plates here. But for some reason they're not. I think it's because they're an imported part. I think they're a McMaster-Carr part or something along those lines. All right. Let's see if I can find out why this weapon is in the wrong angle. We've got 2 different wheel sizes as well. Man, it's been a long time since I've been in this CAD and actually had a look at it. Oh, and all of our electronics are pivoted up out of the way as well. So this is batteries, a switch, and a very warped looking speed controller. The decal that I put on that has definitely not stayed where it was supposed to. And again, on the other side, there was going to be a switch and batteries and all that kind of stuff. The shock mounts on the weapon motor are a bit derp as well. Oh, yeah. Those are very derp. Those should be flat underneath the plate that mounts the motor. And then, yeah, this motor should, so you can see this triangular block out here, that should be down at that angle. And then all of this stuff is down as well. And you can see, like, that's where a serpentine belt goes between here and there. Bolt, I actually had help with Jamie, who builds Iron Tooth, amongst other robots at ARC. He helped out with some of the CAD, so there is a lot more detail in this CAD than I would sometimes do for a design like this. So I feel like I'm missing a thing still, because I'm missing a back and a top, which this robot got, I applied with this robot to BattleBots, which means it needed to have the top armor on it as well. Let me see if I can find in... right. Might be. Oh, okay. That part is called top armor, but it's the front top armor. It's not the top armor. It's the other problem with a robot that has 2 tops on it. You need to make sure you've got everything labeled correctly. Okay, let's see if I open up a different design. If we find a better bolt. Okay, that's definitely not a better bolt. That's definitely a further back down the design path bolt. Ah, here we go. This has at least got things like in the right orientations. So this might be the better bolt here. I don't know why the other one actually isn't all that stellar. Okay. Oh, yeah, we've got artifacts from putting the symbols on there on the inside. That's interesting. Fusion 360 doesn't do a great job with putting decals on things, or at least I don't do a good job with putting decals on things using Fusion 360. I'm sure I'm just doing the wrong things. The Bolt BH is the file with the last modification date. Right, yeah, well, that would make sense. It does seem to be the one that I took the render photos for BattleBots for. Because it does actually... Yeah, see, look, this one's actually got top armor on it. Yay! We finally found it. Yeah. Once I've found the stuff here, I will very quickly show you inside it. Because I think, yeah, heavyweights are interesting. Heavyweights are, yeah, more of a design challenge, he says, not having ever actually had to build one yet. But also, this is something that I will point out too. So not only we've got 2 front armors here for... I was looking at different arrangements of scooping angle and things. But also under here, so this little block is a HDPE or UHMW skid block. So the idea with this was that it would be the thing touching the ground and not the front wedge, because at the time when I designed this was BattleBots' old floor, and people were cutting holes in the floor constantly. So seams on the floor were a massive, massive issue, and the ground game wasn't anywhere near what it is today. So you ended up with people like hitting ledges on the floor and getting stuck. So I was like, cool, I'm going to put a skid plate right behind my wedge, 1 mil higher, or like half a mil higher than the actual face of the wedge itself, which means that this is the point that contacts the ground. So riding over bumps and things should have been okay. The other reason that I was okay with that was that if you look at the weapon here, the weapon height off the ground was tiny. So even like you would need endgame length forks to get under this without being hit. And again, this was designed in 2019, where nobody was running endgame style forks. Then wouldn't you want to chamfer the edge of the skid block? Yes, probably would have. Again, this was a CAD to get 2 BattleBots. It wasn't the final CAD. So, and I think the big secret here is that all of my CADs that I've ever submitted to BattleBots would have needed half an hour of extra CADing to get them to a point to actually manufacture them. And it is some stuff like, yeah, chamfering a leading edge on a part that would then actually get chamfered in real life. It's that type of kind of like little details that would get done before the robot got actually manufactured. If BattleBots is like, yes, you are coming to BattleBots. So yeah, if we take the bottom off, this is the easiest way to see the robot. This probably would have been how the robot was serviced. You can see running old school like mag motors and gearboxes off. I was actually going to run them on Vesks, just Vesks in brushed mode. So, you know, getting all that working. Bring shims to take any wear on the skid block as well. Oh yeah, no, that skid block was a fully replaceable part. I was going to take like 8 of them and just swap it every single fight, basically. Because it literally was just going to be a long, thin strip of HDPE or UHMW. So it was a very easy part to manufacture and an easy and cheap part to have. Wasn't going to take up much space or weight in a crate. So yeah, make 10 of them, bring them with you, no real issue. With them wearing down, you just like use them as you go. Yeah, so 2 Vesks in the back to run the brushed mag motors. Mag motors? Can't remember if these are mag motors or not. They were one of the common brush drive motors at the time. So I was like, cool, just use what works. Get that all working. Waiachi switches, a big old brushless Vesk here for actually an electric car engine, electric car brushless motor. Because, I figured that the power rating on these was going to be way better than any form of like drone motor. So I was pushing this to its limits of rated power to spin up this weapon. But I figured again that it would be okay because it was designed for an electric vehicle. It should be pretty solid. And it was, of course, going to be shock mounted in the frame, as were the drive motors, and as were all the electronics. So the trick here is that the electronics not only are shock mounted, but these internal panels were going to be HDPE, and they were going to have all the electronics mounted to them. So you've got shock mounted plastic that can wobble around. So nothing in this robot should have taken a really big hit. Approximate weight, 250 pounds. That was the goal, was to do a 250 pound robot. The actual weapon itself, if I can find the weapon in the giant set of stuff that is here. Weapon. Okay, let's see if I can find. Right, that one body. Properties. Oh, and of course you can't see my properties thing. The weapon mass was 38 kilos. So of the 110-ish that BattleBots allows for the whole robot, it was a 38 kilo weapon blade, which I think runs afoul of the current rules for how heavy a weapon can be. So it would needed to have been changed and modified. Also, I will say, one of the things that happened with this... just grab the weapon behind you and put it on the scale. Yes. So, about that is actually one of the problems that Bolt had. So, yes, I have a Bolt blade. No, it is not made of steel. It is actually stacked laser cut pieces of MDF. And it wasn't the final thickness either. I think the blade that I have set up on my filming setup, well, I'm not actually at my filming setup right now. The blade that's up behind me is 12 mil thick or something. Not even, maybe. And this blade is 25 mil thick. So over double the thickness of the wooden blade that I swung around in the application video. And that was part of the problem. I built a wooden blade so I could swing it easily for the video. And because B, I didn't want to pay to make the steel blade before we'd been accepted into BattleBots. And C, it was flimsy, like it was thinner than the actual final blade was. And the selection committee took one look at me, easily swinging the wooden prop, thought it was the final steel blade for the robot, and said no. They were like, no, your weapon is going to break. And I was like, that's not... Oh, shit. I should have added a piece to that video of me, like, cutting and gluing and painting that wood to make it look like a blade so that there was some context to the fact that, no, this is not the actual blade for the robot. It's just a mock-up so I can do the final shot of the video, which was me going, yeah, and swinging a wooden blade through some pictures of some BattleBots. Yes. Yes, hello in chat. Some bots with no ground game under the main body are still using skid blocks like hijinks. Yes, so especially undercutters will use skid blocks. I know Valkyrie has a skid block in underneath its spinning weapon. That just makes sense. You need to touch the ground at 3 points. You only have 2 wheels. Make sure that third point skids. If it's not a wedge, skid it. Yeah. Just casually swinging a middleweight in front of you, robot. Yeah, yeah. Well, I mean, that was kind of the whole point of Bolt here, was to just swing a ridiculous amount of energy around the place and just have some fun with that whole concept. um, if you ground an airfoil shape onto the blade, it would generate downforce and hold the bolt to the floor. It's been tried. People have tried it. People have mounted a blade and then a propeller on top of it, and there have been very mixed results. The results you get are not as good as just putting a prop on a motor and giving it space to suck air through. So the blade spinning around with the prop, yeah, it messes up the airflow. So yes, a blade made as a prop shape would kind of get around that issue, but at the same time, you're then cutting weight out of your blade to give an aerofoil effect. The other thing I will say about all of that is when I ran a robot that sucked itself to the floor constantly, like I built a robot that had downforce from an EDF, it chewed batteries like no tomorrow. I've run very powerful spinners in the past, but that EDF robot was a one fight per battery on a 180 milliamp hour battery. My biggest spinners are like 3 fights per charge on a 180 milliamp hour battery. So EDF sucks so much juice out of your batteries. You need so much more capacity to keep that downforce going than you do to just spin a big heavy bar. You really should make a what not to do when applying to BattleBots video. Yeah, yeah, maybe. I mean, I would be qualified at this point, I think. But maybe I'll wait until I'm on BattleBots so that I've got a what not to do and what to do video. Look, I mean, I think, I'm not sure if I've mentioned this on the channel before, but one of the biggest hurdles for me is the fact that I'm Australian. That means that it is so much more expensive to take me than it is to take any other robot. So if I come up with a really cool concept, it needs to be so much cooler than anything else that's applied. Because, so for example, Bolt here on the screen, you are looking at Bolt right now. Any other big slanted angled bar spinner like Apex, for example, is cheaper for BattleBots to get to BattleBots than it is for them to get Bolt to BattleBots. So why would they ever choose Bolt? Basically is the question here. And the answer is really, I mean, they didn't, right? Like, so for me as a builder who has no pedigree in BattleBots, I have a very hard uphill battle to, and a very high bar to clear to make it worth BattleBots getting my robot to BattleBots effectively. And that is just kind of the nature of being in Australia and so far away from everything. Yeah. Just smack them with the steel in it. Well, yeah, that's kind of what happens with the big spinny weapon. For downforce, you'd want a centrifugal rather than actual blower, wouldn't you? More pressure, less flow. I don't know. That so far outside my wheelhouse of things that I have looked into and dealt with, that I really don't know. I will say when I built my 150 gram ant weight downforce robot that had a fan in it and blew air straight up to kind of suck itself to the ground, I just used a drone motor and prop. So look, it's possible that that's not correct and that I really should have been using a motor designed for suction to suck down to the floor. But that's, again, it's just not my wheelhouse. So I used the thing that I knew about and was available to me and worked somewhat. I mean, it worked pretty well. Just smuggle you in the death roll crate. Oh, I wish. I would love that. But also, death roll's on the other side of the country to me, so it's still expensive to get stuff from me to where death roll is, even. Yeah. It turns out shipping heavyweights is very, very heavy and very expensive, so it's hard to do effectively. Make a multi-brain beta weight and sneak it in with Death Roll Team as a multi-bot. A mini-bot. Yes, I like that idea. I have been thinking about contacting a few teams and seeing if anybody wants a mini-bot that is a multi-brain, specifically a dual spinner multi-brain, because if I can take a mini-bot multi-brain in and have it work in the battle box and lofty goal, take a wheel off a competitor in competition. That is like an A+ report card to hand to BattleBots for the next season and be like, you saw what I can do with 20 pounds. Let me scale it to 250 and I will obliterate anything, So that is one of the things I'm considering. There's a couple of teams that I would approach and ask about that. And I'm considering it at this point in time. Admittedly, it mostly crossed my mind over this weekend, so I haven't actually thought too hard about what that would entail. But it's a possibility, I guess. It would be fun to do. Vacuum cleaners use something like a turbo impeller is my logic. Yeah, that's an interesting point. I mean, that would be cool actually for like a sportsman featherweight, is pull a couple of vacuum cleaners apart and use the vacuum cleaners motor, strip the motor out and use their impeller setup to do a downforce robot. That would be kind of cool actually. Yeah. I've got too many featherweight ideas to build. So if anybody else out there wants a vacuum downforce featherweight idea, please go ahead and take that, because I've got too many other things I'm building to even try that at this point in time. Yes, I think that would be very cool. Anyway, it's getting very late for me here in Australia, so I think I'm going to end the stream here. Thank you all for coming along and hanging out and, being here for the stream. Sorry for those of you who were in early and I messed up the start of stream. But yes, I haven't streamed in a while, so these things unfortunately can happen. Hopefully I'm going to start streaming a little bit more. Probably, look, at least once a month is kind of like my lofty goal, ambition, aim at this point. But we'll see. Things do get kind of busy, and yeah. As much as I do enjoy talking with people while I'm CADing, it does also slow down my CAD process a little bit. So sometimes it can be faster to speed through a CAD rather than design. And also, some things I want to CAD on my own so I can surprise you with a video when the time comes. And other things I'm like, nah, we've got a cool bar that we're going to put on a really weird robot, so let's do that together. Anyway, like I said, that's probably going to be it for this stream. Hope you have enjoyed, and I will see you sometime in the future.